Hello, everybody. I hope you're all doing well and you're ready for more math. We're looking at question 19 on our 2012 Fermat paper. The coordinates of three vertices of a parallelogram are 0, 0, so the origin, 1, 4, and 4, 1. What is the area of this parallelogram? Okay, so here we go. We've got our triangles here, or sorry, not our triangles, our three vertices, which would make a triangle. Now, if we think, all right, there's three vertices. What's our parallelogram going to be? You'll actually be shocked to find, well, maybe you won't be shocked, but you'll actually find that there are a few possibilities. We could have a parallelogram that looks like that. We could find out what this point over here is. Or we could have a point over here, and then our parallelogram looks like that. I guess it would actually be a little lower. Or you could have one down here. There's actually 3 points we could use to make our parallelogram. So the big question is, which one is right? Which one did they want me to use? And the answer is it doesn't matter. It really doesn't. Okay? That's why they're leaving this open-ended. So actually, if you picked any one of these points and just tried to calculate the area of the parallelogram using that fourth point, you'd be all set. You'll get the same answer each time. But why is that? So before we actually do the question, why is that? Well, if I have three vertices of a parallelogram, how do you get the area of the parallelogram? Well, you can view it as, if you chopped the whole thing up, you'll find that these angles are the same, here are the same, and you'll actually get two congruent triangles. So they got this side in common here. And so the area between these three vertices is the same as the area over here. Okay, so if I called this area A, we still get A over here, and so my parallelogram is 2A. But we get the same triangle over here as well, so the blue parallelogram has an area of 2A, two of these triangles. And this triangle down here is, again, the same thing. It's still going to be congruent. Okay, so they're all congruent to this triangle. And that's why it doesn't matter which point it is. But now you might realize, oh, it doesn't actually matter what this point is at all. If we make this connection, to find the area of the parallelogram, we just need the area created by the triangle for these 3 points. And that becomes an easier thing to work with. Okay? So how can I find the area of a triangle given its coordinates are 1, 4, and 4, 1? And of course, 0, 0 was the first one we were given. Okay? Well, there are a few ways. There is actually a formula in terms of coordinates that you might memorize off the top of my head. Depending on how much math you've seen, you've done some more advanced stuff with vectors. There are actually ways to use, arrows and vectors, if you're familiar with them, to find the area here. But I'm not going to do anything like that. If you want to, you can read about them. If you know how to do the vector method or if you know the formula, by all means, let me know down below, especially if you know the formula in terms of coordinates, because, it's nice to share with other people and other people read the comments. But here's what I'm going to do. I'm going to put these, it's kind of hard with just a triangle out in the open to work out its area. So what I'm going to do is I'm going to put it in a nice little box. Okay. Now this box is going to have a height of 4 and a width of 4. So it's a 4 by 4 square. So the total area inside the red box is 16. But now I'm going to get rid of these triangles, cut them away, get rid of their area, and what's left is going to be this area. And all I need to do then is double that. But these triangles are a little easier to work out because I can figure out their sides and their right-angled triangles. So we get a 1 here, and if there's a 1 here and the full side length is 4, then this must be a 3. This will be a 1, this will be a 3. And so now the area that we want, maybe call it A again, is 16, the total area inside the red square, minus 1/2 base of 4 times height of 1, minus 1/2 base of 1 height of 4, okay, minus 1/2 base of 3 height of 3. Okay? So 16 minus 2 minus 2 minus 9/2. So that's going to be 12 or 24/2 minus 9/2. That'll be 15 halves. So that's the area of this particular triangle. We need to double it. 2a is the area of the parallelogram. So 2 times 15 over 2. And we can see that's just going to be 15. So the parallelogram we would make, whichever one of the, the blue parallelogram, the green parallelogram, whichever one, they'll all have the same area, and that will be 15. And that's going to be answer A. So we bubble in A. Now we can move right along to question number 20, and that'll finish off part B of our Fermat paper. So thank you guys so much for watching. Feel free to like the video or subscribe if you want to be kept up to date. Leave a comment if you have a different approach to any of these questions. But I'll see you for more math next time.